All right, let's talk about monopoly. Now, as you know, a monopoly is a state of a market where you have only one seller. Now, often people will say, hey, if you got a monopoly, you can charge any price you want, but let's start with an important caveat, which is there is still consumer sovereignty. I feel like I didn't spell that right, but it doesn't matter. Uh, what I mean by consumer sovereignty is even though there is only one place where I can go to get cable in Suffolk County, that doesn't mean that they can charge anything they want, because at a certain point, people just stop buying. And this is the basic situation that a monopoly is trying to deal with, which is given that people can choose not to buy, how do they set a price to balance, on the one hand, losing customers, but on the other hand, charging a higher price to the customers that they do have? Oops, we're still here. So way back in my notes, I've got some stuff. This stuff is irrelevant, but here is just a nice illustration of the problem facing a monopolist. So here I've got my favorite demand curve, my 101 demand curve. So that just says at a price of 101, we sell 0 units, and at a price of 0, we sell 101 units. And that's going to make it really nice and easy to try and figure out what the elasticity is at any given point. We can deal with percentages really easily with this particular demand curve. But what really matters for our discussion here is these 3 different rectangles. We're trying to figure out which of these rectangles do we want. So on the one hand, you charge a really high price, but times only a handful of consumers, right? So for this demand curve, at a price of $100, you only sell 1 unit. At a price of $1, you would sell 100 units. So both of these are equally bad, but they're illustrating this idea of a high price or making up for it in quantity. And it's going to turn out that for this demand curve, you are going to maximize your total revenue right in the middle. But let's go ahead and see why that's the case. So, given this demand curve, what we want to do is we want to convert this into something that we can maximize. And we kind of did a version of this earlier on in the semester in 250, but here's really what's going on. We're thinking about total revenue, which is just price times quantity. Quantity we'll think of as our choice variable, right? So it's sort of natural for you and I to think about this in terms of what price do you sell, and that determines how much people buy. But mathematically, it doesn't really matter which way we go. So we're going to stick with tradition and think about setting a quantity. This is what you would do, by the way, if you were, let's say, a famous artist. So Banksy sets a low quantity so that the price of his goods are relatively high. Or if you think about, what was that situation, the Wu-Tang Clan, I guess it was a few years ago, they released one record, they only gave 1 unit of it, so they were way up here. They weren't really monopolizing, but they were setting a quantity and letting a price emerge in an auction. All right, so our price, let's think of that as a function of quantity. And then that way we are thinking of our overall situation as a question of quantity. I'm going to keep the math here relatively simple. I'm going to use my 101 demand curve again. And I lost the page, but that was, I believe that was just 101 minus Q. Right, so there is our price. And then we multiply that by Q. And so now we've got total revenue equals this equation, which we can simplify to 101Q minus Q squared. Right? Not too bad. Now, let's apply a little bit of calculus here. And if you're a principal student watching this and you don't know calculus, don't worry too much. Just treat it as magic for the time being. But what this is going to do, we're going to take the first derivative of this and that's going to give us the marginal cost, or sorry, the marginal revenue. What is the change in our revenue as we sell more units? And in this case, our marginal revenue is going to equal 101 minus 2Q. Now for the principal students, here is a handy rule of thumb. If we're looking at a straight line demand curve, the marginal revenue curve is going to slice right through the halfway point of any horizontal line. So for this demand curve, we know it hits at 101. We know it's going to cross through at 50.5. So if we draw on our marginal revenue curve, we get something like this. So if we want to just maximize revenue, well, selling a small number at a really high price means that if we sell more, let's say we're starting here, we sell more, we're going to have to lower the price in order to do that, which means we're going to be missing out on this money, but we're going to be bringing in this whole big rectangle. So let's try and very roughly pull that out, right? So out of this whole rectangle that you're adding, we could net out what you're losing, and this is your net gain. And hey, I did this pretty well because this horizontal line is pretty much hitting my marginal revenue curve for whatever this quantity is. We'll call it Q0. All right, so at Q0, selling that extra bit means that we're adding about this much to our revenue. Right? We're really adding this much and losing this much, but if we take that away from what we're adding, our net effect is we're adding that much, which means we want to be selling this unit because it means more revenue for us, and we're going to keep doing that until we get to this point. So if we're strictly trying to maximize our revenue, we go to where there's no more additional revenue as we sell more. Now the question of what does a monopolist really want to do? Well, it's not as simple as just maximizing revenue. They care about profit. Let's go ahead and start this again. We've got a demand curve. I'll keep my marginal revenue in red. And I want to make just a simplifying assumption. I'm just going to think of a really simple cost curve. I did it again. That's MR, not MC. So I'll call this MC for marginal cost, and C becomes an R, marginal revenue. So the profit maximizing output for the monopolist is to find where do these 2 points cross, because if they go any further, they're adding a small amount to their revenue, but they're adding a bigger amount to cost, right? Which means they're making a loss, at least on the margin, and they would do well to cut back on their output. If they're anywhere to the left, moving further right means that they're adding more revenue than they are cost, and so they want to move in this direction. So that's going to give us the profit maximizing quantity, which we'll call Q star, and at that quantity, they're going to sell at this price. This is basically the price that they can get away with. Given that there is this much to sell, they basically try and figure out what will the market bear. How much, or really how many consumers are there willing to pay that price or higher, right, versus any other quantity. If they sell more, they're going to have to lower the price to find those extra customers. This particular level, that should have been a P. This particular level, P star, ignore its little extra leg. At this level, P star, this is going to drive me nuts. Let me get rid of the whole thing. P star is what they're bringing in. They're paying some cost, and for this really simplified version, they're ending up with some amount of profit, right? And that profit is going to be what is their total revenue minus their total cost. And in this case, our marginal cost, we haven't given a specific thing, but let's just say our total cost was something like, we might have some fixed cost, which I'm going to be agnostic about for now. But then we'll say, let's just make it $10 per unit, right? $10 times Q. So if they sell an extra unit, they increase their cost by $10. And that's what this horizontal line represents. One more unit, this much more to their cost. Sell a bunch more units, you get this much more cost. Now, I did kind of make it a little upward sloping, but that's just sloppy graphing. So, given this, what can we do? Well, we can come back to our total revenue, take away our total cost, which is going to be just something minus 10Q. But really what we're going to end up with, I'm just going to take directly from here, pi equals 101Q, and then they're going to be taking off all of this. So some amount of fixed cost, and then minus 10 times Q. So we got 101Q minus 10Q, and then also minus Q squared, which we can simplify down to 91Q minus Q squared. And when we do our same little bit of calculus magic here, what we end up with is pi prime equals 91 minus 2Q. And we should be able to see that if we just divide 91 in half, that's going to give us Q star. All right, that was a really simple, quick recap of Monopoly, I hope. I did kind of gloss over some stuff, so as usual, feel free to ask any questions.